Hey guys, welcome back to my channel. In this video, we are going to learn about the queue data structure. So, a queue data structure follows something called as FIFO principle. It is first in, first out. It simply means that the element which is inserted first into the queue will be the first one to be removed. Alright, we cannot remove element from the queue from the middle or from any specified index. No, a queue works like this in a first come first serve basis. We have two major operations here, that is enqueue, that is adding an element into the queue, and dequeue, that is removing an element from the queue. We will use two pointers for our utility, that is a front pointer pointing to the front element of the queue and a rear pointer pointing to the last element of the queue. So suppose in a real world example, few men are standing in queue for a for their work in bank. Okay, so they will be treated in a first come first serve basis. So first the bank will serve the man at the front. So after this man is done with his business, he will simply leave the queue and go home. Alright. So after he goes home, the men behind him will come forward. Isn't it so? So when these men come forward, the front pointer that was previously pointing to that man will now point to this man. This man is at the front of the queue now, and the bank will now serve him. And the rear pointer will point to this man at the end of the queue. Alright. So this was basically the dequeue operation. Understood? The dequeue operation, removal of an element in a queue. And then the other one is the exact opposite, that is enqueue, that is adding an element in queue. Suppose the three men are waiting in queue for their turn in the bank, and another man comes and joins the queue. So now what will happen? Now we will simply put the rear pointer from this man and move it to this man at the end of the queue. Alright. So this is basically the entire queue data structure. Okay. So now let's move to the code implementation in Java. So as you can see, I have created a custom class, that is custom queue. Okay. In this we will implement the queue data structure. Okay. So first we will take the class variables, that is private int data to store the queue elements. Then we will take two pointers, that is front, which will initially point to 0, also a pointer end which will also initially point to 0. Also, to keep track of the size, we will take a variable size which will be equal to 0. Okay. Now we will create a constructor, public custom stack, a parameterized constructor that accepts an integer size, and this size will be used to declare the array inside our queue custom queue class of capacity size. Understood? Custom queue, sorry, my mistake, custom queue. Then we will implement the utility methods, that is full and is empty. Public boolean is full. This method will check if our queue is full or not. So when do we consider our queue to be full? When the size will be equal to data dot length. When the size will be equal to the length of the queue, we consider the queue to be full. So now when is the queue empty? A queue is empty when simply the size is equal to 0. Alright. Now we will first move to the first major operation, that is enqueue operation, insertion or enqueue. public boolean enqueue, an integer item to be inserted into the queue. We will first check if the queue is full, and if it is full, we will simply return false and go out of the method. If not, data end post increment operator plus plus will be equal to item. What this means? Suppose first the value of end is 0. So in Java the array indexing starts from 0. So data of 0 will be equal to item, and then after incrementing the value of end will be 1. Okay, then we'll increase the size plus plus, and then we will return true. This is the enqueue operation. Understood? Then coming to the dequeue or removal. Public int remove, and this method will throw an exception because suppose our queue is empty, then how can we implement the remove operation there? Okay, if a queue is empty, then we cannot implement the remove operation. So we will check if the queue is empty. If it is empty, we will throw exception that the queue is empty. Okay, if not, we will store the element at the front, okay, in a variable named removed, and then to readjust the queue we'll do something like this. Int I will be equal to front I less than end minus 1 to access the second last element, and then I plus plus. We'll loop through the queue, then data of I will be equal to data of I plus 1. We understood what is happening in this for loop in the diagram previously. Then we will reduce the value of end, then size will also decrease, and then we will return the removed variable, that is the element at the front of the queue. Exception, what is it? Yeah, throw new exception. Alright, then we'll also have a method to access the front element of the queue, which will also throw an exception, because if the queue is empty, then how can we access the front element? Throw new exception, queue is empty. Okay, now we will return data at front. Understood? Then we'll implement the display method to display the queue. Public void display for int I will be equal to front I less than end I plus plus. If I will be equal to end minus 1, will not include the arrow mark data of I. If not, we will include the arrow mark. Data of I plus this. Okay, then after printing, we'll print a blank space to make the output screen look good. Alright, so as you can see, our custom queue class is fully implemented. Now let's move to the main class to test our custom queue class. Inside our main class, we'll create a method, an object of custom queue. Custom queue will be equal to new custom queue of size 5. We'll insert a few elements into it. What is it? Didn't I do it? Okay. Insert 10, then we'll do insert 20, we'll insert 30. Okay, just to try. Then we will display. Let's see if it works. As you can see, first 10, then 20, then 30. Alright. Now let's try the front and remove operation. Okay, so since in both the functions we have included an exception throw, alright, so we will always use so when implementing them in the main class, we will always surround them in a try catch block. Alright, so if an exception arises, we can catch it and then display. Try system dot out dot println removed element will be equal to plus removed, no, q dot remove. Okay, isn't it so? Did I? Yeah, I did it. What is the error here? I will add the catch clause, don't worry. How dot println removed element will be equal to plus q dot remove. Okay, now let's take a look at the front element, which will be equal to q dot front. We will add a few more elements into our queue. Okay, catch exception e system dot exe out dot println e dot get message. Okay, let's see. As you can see, the original queue is 10, then 20, then 30, then 40, then 50. First we remove 10, then we remove 20. After these two are removed, the front element is 30. The front element is 30. So we are done with queue. Thank you for watching the video till now. Give it a like, share and subscribe.